Launched in 2008, the Airbus FlyYourIdeas competition places Airbus at centre stage in universities across the globe by challenging students to innovate for the future of aeronautics and space. Since it launched, over 22,000 students have registered to take part from over 700 universities in over 100 countries. And this year, 6 challenges were put to the students, covering the areas of electrification, data services, cybersecurity, the Internet of Things, artificial intelligence, and mixed reality. The 7 finalist teams headed to Toulouse at the end of June to work on their ideas, prototypes and pitches before presenting in front of a jury. I caught up with the teams when they arrived in Toulouse. Team Airfish from the University of Cambridge in England had come up with an ocean monitoring system using satellite imagery and video imaging technology, which they hope can help governments combat illegal fishing, reduce the bycatch of endangered species, and decrease damage to marine habitats.
We are MBA students from University of Cambridge, Judge Business School. We have 4 people. Fala, Martin, and Nathan are from Indonesia, and Keiko is from Japan.
Okay, and tell me about the technology that you're developing in your solution.
So the idea Airfish is basically using a constellations of microsatellites to more effectively monitor our oceans, specifically illegal vessels, because the aim of Airfish is to better solve the problem of declining stock of fish that we have. And the advantage of using microsatellites is that it is cheaper than relying on the existing system of large satellites, and it should also be faster. And that's probably one of the key problem with the existing system.
Okay, so where did this idea come from? How come you decided to work on this particular problem?
So it comes from, we come from large fishing countries. Indonesia and Japan is one of the biggest country producing fishing productions in the world. One of the key issues that is faced by the government currently is the large amount of illegal, unreported, and unregulated fishings. They spend around 30 million USD annually in order to monitor this, which is a very large expense. And there has been some policies recently, for example, like blowing up the illegal vessels in order to deter illegal fishing activities that has been on the rise. So we're thinking we could contribute in preserving the natural richness of marine resources in our country and help our government by utilizing this Airfish solution.
I think just to add on that as well, we were inspired specifically by one of Airbus' recent project, which was OneWeb. And OneWeb is right now, I think, the biggest microsatellites project. I think Airbus is planning to launch around 900 a constellation of 900 microsatellites, and we were thinking, what can you do with microsatellites? This new new inventions in the space technology, and if Airbus is doing it for telecommunication, which is the aim of OneWeb, then we as a society is facing this huge problem, which is our ocean's health. And we realized that why not use that? And we don't really have any good answers to the questions, why is Airbus not doing that? So that's why we're pitching this to Airbus.
Okay, tell me a little bit about the process so far then, from when you first entered FlyYourIdeas up until the finals this week.
Okay, it's quite interesting because in every round, our idea is kind of like evolved. So in the first round, we pitched about using microsatellites to determine the potential fishing zones. But then later on, we realized that actually illegal fishing is like one of the biggest problem in the world, with like 25 billion USD being lost because of this. And us, trying to figure out more potential fishing zones probably contribute to that $25 billion. Yeah. So in the second round, we actually tweaked the idea to, why don't we use it to help the government to prevent illegal fishing? So that's one thing. The other thing that we figured out in round 2 is also, apart from wild capture, we also have a growing aquaculture industry, and we also use we can also use microsatellites to help the aquaculture industry, which is to prevent or to manage red tide that is happening currently in aquaculture. So basically, using the same constellation of microsatellites, we can both help preventing illegal fishing and also managing red tide risk.
Team AIQ Inspect from Saarland University in Germany developed an automated intelligent real-time quality inspection process that exploits human-robot collaboration. They want to replace the human aspects of rivet inspection with an intelligent automated process which determines the quality by classification based on images and physical parameters whilst riveting in real time.
I'm Daniel. I'm from Saarland University and I study computer science, currently in my 5th year bachelor.
I'm Aditya, and I'm also pursuing masters at Saarland University in computer science itself.
And my name is Tobias Masiak, and I'm a PhD at the University of Saarland and research assistant at SEMA. And together we are AIQ Inspect, which means Artificial Intelligence Quality Inspection. And our goal is to improve the quality inspection part in the production of airplanes, and therefore we are using sensor data fusion. That means we are collecting data from cameras, we are collecting data from laser line sensors and from force torque sensors, and by combining all of these data in combination with artificial intelligence algorithms, we are able to give a statement for the quality of the production process in the riveting process in the aircraft production. And finally we try to make this idea like feasible to the operator, which means we are sending the results of the AI to a Microsoft HoloLens. So here we are using mixed reality technology, that the operator can see the result which has been done or calculated by the artificial intelligence.
In real time.
So what led you to choose this topic for your project?
So we already had been working on a similar project which was actually automating the riveting process, and then one day we were just sitting around and then say, okay, we already have the robot, so why not put on some more sensors on it and then also inspect the things that we have just riveted. And that's how we came about this particular project.
Why did you decide to join the FlyYourIdeas competition?
Yeah, we are active in the aircraft production, or we have like the knowledge from these previous projects, and that was like the logical consequence that when we saw the project that we definitely have to participate. So we have been working on these topics as a team in the past, and for us it was like the chance to get in contact or to get more in contact with Airbus and to showcase the results which we have been working on.
So particularly for me, I would say that I was always excited by aircrafts and I wanted to be a pilot first, but then again due to some circumstances I wasn't able to do so. So this, I think, being an engineer, this is the closest thing that I can get to in making aircraft and inspecting aircrafts, making them better, safer.
Okay, so can you give me some examples of the technology that you've developed in order to come up with this solution?
Yeah, so in particular for the quality inspection itself, we are using machine learning, supervised machine learning, in which we are using classification using neural networks. And as we are using an array of sensors right now, so we are getting data, as Tobias just told, from laser line sensor data, camera, and also force torque sensor data. So we use convolution neural networks for classifying images and deep neural networks for classifying sensor data, and then we put in the results from both the neural networks and then in the end give the final decision whether the inspected part is good or bad. And in the end, in addition to that, we are also using as a visualization tool in this particular application, we're using the HoloLens holograph superimposition.
And finally then, what has your journey been like from starting the competition to getting to the finals this week?
It was quite an exciting journey. When we started first thinking about the idea, I think it was when did we start? In September, right?
Yeah, around September.
Yeah, around September we started thinking about the idea, and then after applying and getting the notice that we got to round 2, we could then start collecting data.
Yeah, made us realize that it's possible. This particular application possible. Makes sense. So kind of got an acknowledgement. The things that we are doing make sense.
Yeah, and we could actually start collecting data to train the neural network, which took around, I don't know, a week or 2. because we collected about 2,500 rivet points, or we riveted around 2,500 rivet points and collected all the data, then did the labeling, and it was quite a tedious process. Yeah.
The Polytechnic University of Milan in Italy put forward Team Movies, who saw an opportunity to use the Internet of Things to create a smart wheelchair that they hope will revolutionise the air travel experiences of passengers with reduced mobility by converting a designed class of detachable aircraft seats.
I'm Tommaso.
Mario.
Daniela.
And I'm Vittorio.
So how did you guys get together to enter FlyYourIdeas?
We studied in the same university, and we actually started bachelor together. So we knew each other, and we started this project in September. We knew about the concourse, and we were interested in this kind of innovation concourse, and basically we gathered together and we thought about some innovation idea, and we came up with Swan.
So tell me then a little bit about your project. What's your solution that you're developing?
Okay, so SWAN stands for Smart Wheelchair for Air Travel Needs, and is our idea about how to improve passenger experience of people with reduced mobility. Actually, at this moment they find some difficulties on boarding the plane because they have to be transferred from their personal wheelchair to the seat. And so we would like to delete all this difficult process by transforming the seat, the aircraft seat, into the wheelchair of the passenger, thanks to SWAN, that is a driving unit that goes under the seat and transforms it in an electrical wheelchair.
Okay, and how come you decided to work on this topic?
Because one of our members have personal issues. His sister is have this issue. It's one of this passenger with reduced mobility, and when he graduated to come to the party, the sister had some problems to come in Milan because of the plane. So among all ideas we had, we chose this topic because it's personal and because we care about.
Okay, so talk me through your technical solution then. How are you solving the problem?
We start from an already existing seat. We want to transform it and making the seat that is next to the aisle like detachable, thanks to a very simple system. And in this way, this driving unit can be installed under the seat, and then the passenger, just with the smartphone, will connect the smartphone with this driving unit and use it to go inside the cabin, but also inside the airport, and just enjoying his trip all along from check-in to arrival.
Okay, and what's the journey been like for you through the FlyYourIdeas process, from starting in September to making it to the finals week now at the end of June?
Like a game, I think.
Yes, it's been crazy.
It started like a game without hope to arrive at this point. But we at each round have done our maximum, and that's all I think.
Yeah, I think being here right now is very exciting, because in September it was just a faraway idea, and now we can see it for real. We are prototyping it. So we can show also to people how this idea can be feasible and can be made. And so I think it's incredible to be here.
Representing the University of Strathclyde in Scotland was Team Osprey. By replacing the traditional method of cooling electric motors with a water jacket or submerged cooling with a cooling system integrated inside the body of the motor itself, they hope to provide mass-effective motors for future urban air mobility and hybrid electric aircraft.
And I'm Kieran, and this is Pierre.
Nice to meet you.
So tell me a little bit about your project.
So our project is a new electric motor cooling system that's trying to enable electric flight.
It's based on direct metal laser sintering as the primary technology to be able to get this cooling system to happen.
So how did you guys get together to form the team, and what prompted your solution?
Well, actually, we've been working together for a couple of years on other electric aircraft-based topics. We started out with a feasibility study on the aircraft as a whole, to make sure the physics and everything were okay, and that electric aircraft weren't some kind of pipe dream. Yeah, so we identified a bunch of requirements that would enable electric aircraft, One of them is a very high efficiency in the propulsion system, and that the propulsion system has to be extremely mass efficient. It has to generate a lot of power per kilogram of whatever your propulsion system is, and that's what led on to this project.
Yeah, I think we both have this dream of enabling electric aircrafts, and it's how we met originally. We just talking. We had very similar honours projects, and to do with trying to like he was saying, like, what you need for electric aircraft, and we realised we had this similar interests. And when we heard about the competition, we knew we just had to jump on that as fast as possible and try to come up with one of the solutions.
A couple of days' notice.
Yeah, a couple of days' notice to put everything together, and we knew because we needed this very mass efficient system for the propulsion, we decided to go for trying to improve electric motors.
So talk me through some of the technical details of your solution then.
Sure. So you start off, you have you have to choose the electric motor architecture to be the most mass efficient. And we started with a radial flux motor and moved to an axial flux motor architecture. So already we're at industry best of what we call power density, right? So the power per kilogram of mass. On top of that, we now take the rotor, the moving parts holding the permanent magnets in this architecture, and we direct metal laser sinter, so like a metallic 3D printing. We use that to build the cooling system into the rotor itself. So it's right close to the magnets, as close there as you can get, right? It's the source of the heat. And the same with the stator. We were able to 3D print the stator and use direct the channels round the coils and follow that internal to the body, meaning that all your coolant is not a submersive cooling system. It's internal, it's all locked and sealed in one system. And it opens benefits such as you can draw vacuum inside the motor. You elongate the life. You take away things like windage losses, which is a form of drag that forms on the rotor as it's spinning in a medium, which if you're using submersive cooling, it's spinning in water, right? So you get a lot of drag.
Or even coolant, which is even more viscous.
Even worse. Right, exactly. But it opens up it opens up almost benefits that you don't see when we started designing it. Which is you're able to now put in a hell of a lot more power into the motor than you used to be. So it doesn't melt the windings and you're getting past that temperature limit, but simultaneously you're removing the mass as you 3D print the channels. Or other things like if you're using the direct metal laser sintering method, you can honeycomb the rest of the structure that you're not using for channels. And so the structure becomes mostly air and a little bit of metal. So you're even more mass efficient.
So we hope this, as we've been calculating, when we take this original sort of the best motor we can find, and then mathematically model it, and then put our cooling system in, we get really good percentage upgrades on the power density, which is what we want. And we're trying to reach. What was this number we're trying to reach?
Around 10 kilowatts per kilogram, which is the calculation for the power density of a gas turbine.
Yeah.
So that's the standard for what we would say is you're able to market that to companies like Airbus.
Yeah.
And say this is a comparative propulsion system.
So we're getting really close to that figure now.
Well, it depends which motor we use.
Yeah,
a few of them reached the 10 kilowatt per kilogram mark. But from the selected ones, we took the best industry axial flux motors, applied our system to it, and we're seeing an average of about 40% improvement in power density.
A second team from the University of Cambridge, Team Seren, were proposing a solar windmill, a novel method of electricity generation for spacecraft using trapped high-energy particles. Using two concentric aluminium spheres, the proton flux and ambient plasma trapped in planetary magnetic fields can be harnessed to generate power.
I'm Billy, a first-year natural scientist at Cambridge.
I'm Peter, second-year natural scientist at Cambridge.
I'm Liam, second-year physicist at Cambridge.
And I'm William, a research fellow in astrophysics at Cambridge.
Now, Seren, that's the Welsh word for star, isn't it? I'm assuming that's where that's come from.
Yeah, it is. It's just, I'm from Wales, and it's not a language that's really represented much on the global stage, so I thought it would be nice. We like the word, and it fits with the whole concept, so yeah.
Okay, so what is your concept?
So it's basically, we are using the high-energy particles that are trapped around planets by their magnetic fields to produce electricity.
Okay, so you're going to have to give us a bit more detail about how does this work?
So you have it's made of two spheres. You've got an outer sphere and an inner sphere, And the idea is that you have protons in these radiation belts which have got enough energy to penetrate through the outer sphere but not the inner sphere, so they're absorbed,
so they get trapped
they're
in
absorbed
between
on the inside, and so that charges the inner sphere positively, and there you've got a voltage difference between the inner sphere and the outer sphere, so the outer sphere loses its charge to the plasma around it. So
you now have this voltage difference, but it's still in space, right? So how do you then make use of that electricity?
Well, so it all depends on what your application is. So you could use it as just a power system for a space probe. So say something like JUICE, the upcoming JUICE mission, going around Jupiter thanks to its high strength of magnetic field. There's a lot of energy there for that. Alternatively, you can use it as a power source for things like asteroid mining or just planetary usage by sending a bunch of them up into optimum orbit and beaming the power back to wherever you need it using microwaves.
Okay, so where did this idea come from?
So I was just quite bored over the summer looking at things to do. And I really like space, so I just saw the competition. I gave a thought to it, and I've always just really enjoyed space. And the thing was, I was thinking like, well, what are the problems we need to solve in space at the moment? And one of the ones that's always been a massive problem is getting through things like the radiation belts. But it just struck me that if there's so much energy in the radiation belts, we have to avoid them. Why can't we use that energy in some way? Mm-hmm. And that was really where it came from.
Yeah, and you're not only using the energy, you're also using the structure of the generator to provide the shielding for the spacecraft. So it's got sort of a dual function.
What's quite interesting is charging in space and spacecraft is it's an issue that there's many papers on, and NASA and other space companies has kind of really experienced this problem, but we were trying to turn the problem into a solution, turn around on its head, and instead of seeing it as a problem and trying to fix it, we harness it and say, why don't we use it to power electronic devices like cameras and sensors and things you need for maybe scientific missions or mining or so forth.
Okay, well, tell me a little bit about your FlyYourIdeas journey then, from coming together as a team to making it through to the finals this week.
When we all knew each other before the start of the competition, and I remember I was trying so hard to convince people to join the team, because in the beginning it was just me. I was messaging all my friends like, guys, this is a really fun thing to do. And I was like, oh, we probably won't get that far. It'll be good fun. We'll enjoy ourselves. And
you were very persuasive.
I remember getting it.
You had the idea that we wouldn't have to spend too much time on it,
and you fell for that. The rest of you fell for it.
We didn't think we'd get to round 2, let alone the final.
Yeah, so I remember getting a call, this late evening on October, and I was like disgruntled and kind of woken up from sleep, and I said, hello, Billy, what's up? I thought there was some problem back at, he needed me to help him move stuff. And he was like, oh, Liam, I've got this really, really interesting idea. I was like, Billy, it's 2 a.m. in the morning, can this wait? He's like, no. And he said, oh, there's this competition Airbus is running, and it's really interesting, innovative, and quite inclusive, and why don't we try our hand at it? And I said, yeah, sure. And that's pretty much it.
In your sleep-deprived state. So there we go. I think there's a lesson learned there. Guys, it's a fascinating idea. Thanks very much.
Thank you very much.
Thank you.
Team Vaca hail from Argentina and the National University of La Plata. Their idea for an Earth observation database application for stock breeding administration is an integrated service for stock breeders using meteorological and Internet of Things data applied to agriculture. They hope to help stock breeders better manage their activity and save time.
I'm Pilar Tagliero. I study aeronautical engineering in La Plata, Argentina, at the National University of La Plata.
Hello, I'm Tamara Teplitz. I'm from Tandil, Argentina, studying veterinarian at the university that it has a long name, Universidad Nacional de Centro de la Provincia de Buenos Aires.
Wow, you weren't like that was a long name.
I'm Ana Bianca Ramulo, and I'm studying aeronautical engineering with Pilar in La Plata University as well.
Hello, I'm Franco. I'm from Buenos Aires, and I'm studying computer science in the University of Buenos Aires.
Okay, so you really have a mix of skills and backgrounds in this team, quite a diverse mix. How did you guys come together to enter FlyYourIdeas?
It's
so
funny.
complicated.
Yes, it's a long story.
Yes, our academic mentor is our professor at the university, Anna Snai, and he proposed us to participate in the competition.
I'm his nephew in law, and Franco.
I'm friends with Anita.
Yeah.
So.
Okay, so you were thrown together.
We knew us. We met together for the first time here at Toulouse. In fact.
Okay, so you've really been working on this project remotely
online.
up till now.
Yes.
Okay, so tell us about your project and your solution.
We want to develop an application based on satellite images and RFID technology in order to provide an integral and easy-to-use solution for stock breeders, so they can increase their income up to the 20%, and also reduce the time they spend monitoring the field, so increasing their free time.
Yes, in South America we have extensive fields which are environmentally speaking so much better than feedlots, and extensive fields are really extensive. They are really huge, and it gets a lot of time and effort to watch every paddock that is the division of the field and searching for every cow it's okay and everything. And usually stock breeders live in the cities far away from there, so we intend to have an application in the cities that gets easier control of their field, and sometimes even they don't have the control of the accounting of cows, and just putting with the RFID tags they know exactly the amount of cows, how are they, how healthy they are, the amount of pastures, and the climate information, alerting for droughts or floods, and everything just in the palm of their hands.
Okay, so big university names and big fields, that's what I'm taking from that so far. So tell me a little bit more about the technical solution.
So the technical solution is take the satellite images, combine it with this what Samal was talking about before, that RFID tags, to track the cows and try to monitor them, where are located each one, and to combine all this information to give a stock breeder like a more big picture about their fields, and to analyze where here you can have like this quantity of cows, you have this quantity of cows, and use the satellite images to say, well, here you have like this quantity of pastures, so you can feed like X amount of cows, and you have in this other place like this other quantity of pasture, so you can feed this other quantity of cows, and also integrate weather information to say, well, maybe here is like a possible fire risk, or maybe a flood risk.
But the thing is that we're not going to track the cows. We're not going to see all the movement. That's what now the solutions that already exist do, and that is expensive. Our main objective is to develop something cost effective, and so in order to reach that, we're going to install the antennas only near water trough. So we're going to detect if the animal approaches to drink, and if not, we can infer that the animal is ill and send veterinary assistance on time.
Now, as you've heard, all of the teams who took part came up with truly inspirational ideas that could have tangible business benefits, but only one team could win the competition, and that team was the Zero Heroes from the Delft University of Technology in the Netherlands. Their batteryless wireless buttons for aircraft allows for the removal of cables, and therefore not only a reduction in weight, but also simplified retrofit and maintenance requirements.
I'm Sujay Narayana, and I'm the team leader of this team.
I'm Niels Hokke. I'm a master student. I'm also part of Team Zero Heroes.
I'm Nikos Kouvelas, and I'm a PhD student, and I am another member of the team.
I'm Vijay Rao. I'm the second mentor for this team. Primary mentor is Dr. Venkatesh Prasad, who's an assistant professor at Delft University.
There's one more person in the team. It's Ashwij Narayanan, and he's working in the mechanical lab, working on the prototypes.
Okay, so tell me about your FlyYourIdeas project.
So our project is batteryless, wireless systems for the interior of the aircraft cabin. So basically now it's the era where innovations are going on, especially with the Internet of Things. So we see that Internet of Things are being implemented in the cabin. For example, even Airbus is targeting on similar kind of approach. For example, like Skywise, where they want to go for data-driven approach, where they want to monitor cabins and seats and something similar. So ours is bringing IoT. And it's a simple, safe, sustainable. So when I say simple, the system that we provide is miniaturized, agile, and easy to deploy. Basically, it's a batteryless wireless system. So with a single on-off trigger of the switch, we target applications such as reading light, let us say, where they are connected using wires as of now inside the cabin. We target to remove these cables. So this is one of the applications. This is a wireless batteryless switch, which is zero energy, so it is powered with the mechanical movement. So when I do this, I can just turn on or off the light.
Okay, so yeah, it's I mean, yes. This isn't making great radio, if I'm honest, because we can't see what you're doing. So let's try and describe what this is. It's a physical switch, a bit like a light switch, but it's not connected to anything, right?
Yes.
You can just hold it in your hand, and when you press it, you get that physical click, and the light turns on over there.
Because of the click, you are harvesting energy, so it's power from you and power to you. So you are the one who is going to generate the power. So it's basically because of the user action. For example, let us say the person, he latches or unlatches the seat belt. Because there is a movement, we harvest the energy from it, and we monitor if the seat belt is actually latched or not. It's about providing the passenger well-being and comfort.
Okay, so how did you guys get together in a team, and where did you get your idea from?
I'm doing my PhD at Delft University, and one of our projects, and most of us are working on wireless systems and zero energy systems, and this is one of the projects that we are working on. And when we saw the announcement on the FlyYourIdeas concept, and we thought, why couldn't we apply this for the aircraft industry?
Also, my PhD was on ambient energy harvesting wireless systems, so obviously this was kind of a smooth thing to transfer to the next generation PhDs and postdocs or master students. Yeah.
Okay, guys, what about you? How did you guys get involved, and why this particular solution?
Similar reasons. So my master's thesis is on a similar topic, and I think the reason we applied for the competition is we are like science really focused on the theory, and now we get the chance to really apply our knowledge and build a business case and see how far our knowledge can take us and really build an application.
And how has the FlyYourIdeas process been for you?
It was like quite a long journey from the beginning to start putting our ideas together and bring our mindsets together and start working and applying. But it was quite exciting until now, and we're still having a great time here.